What's going on, guys? So today we're going to go ahead and learn a little bit about infrastructure as code. So what is infrastructure as code? That is the question we will start with. So essentially, infrastructure as code is a way to essentially write code that provisions infrastructure on, say, a cloud provider, on-prem, or just hybrid premise infrastructure provisioning. So there's a number of different infrastructures as code providers. The one that we're going to be looking at today is called Terraform. So that's what you guys see in front of me here. And essentially, what this is a way to define your entire infrastructural system up in hybrid prem. So we'll take a look here. So we'll start from the top and we're going to work our way down, talking about how each component of the system has sort of an implicit dependency on components that are provisioned previously to that component being provisioned. So we'll start up here. So we see, in this case, we're going to be using Terraform, which again can provision to any number of cloud providers to actually provision infrastructure on Azure. So we're going to go ahead and look at this now. We've got resource, Azure RM, resource group. So this is the Terraform designated name for this resource that allows us to essentially specify some parameters for how this resource is to be created. So a good way to think about this is to consider a software object. So if we go back to a class, if we consider a class, and a class has a number of attributes, and these attributes are essentially assigned to that class. And now when we're provisioning cloud infrastructure, you can think of all the traditionally hardware appliances such as routers, such as network interface cards, and virtual machines, or we'll say, what's the term? The physical hardware for the machine. This is all virtualized. So in a sense, they are all now software objects that can be parameterized. And that's exactly what we're doing here. So when you see this here, you see Azure RM resource group. And we're going to call it main for the remainder of the file here. We're going to be able to reference this resource group by this main assignment. So essentially what we're doing here, we'll talk about the kind of hierarchical aspect of provisioning cloud environments. So essentially you have your resource group, and a resource group is a way to essentially just logically isolate a set of services or a set of components. And these components could be anything. They could be, like in the previous video, could be a Docker container or a Docker container container registry more generally. They could be an Azure App Service. They could be a database. They could be Azure SQL. So in this case, we're actually just going to provision a single virtual machine inside a virtual network. But as you're going to see, there's a number of implicit dependencies that are required in order to actually provision that single virtual machine. So the first one of these is the resource group. And so what we see here is the resource group has a name and it has a location. And what we see is that these names and locations are being assigned by variables. So in Terraform, we have this ability to essentially create variables, and these variables are then passed into these templates or passed into, we'll say, this main file, or however many. You can have a number of files with Terraform resources, but we're going to stick with one single one called main for now. And essentially what it does is it passes these variables, just like you might pass variables to a class when you're creating an instance of it, okay? So we can go ahead and pass these variables. So we reference them with these, with the newer Terraform syntax, you can reference it with just var.location instead of having to do this interpolation syntax that you see here. So we should be able to do, oh, well, no, because we need resources to be, resources as a string, we need that to be part of it. So we're going to have to use the interpolation syntax here. But essentially you can see we can do var.location beneath that. So this will go ahead and actually reference this location variable that we see in our variables.tf, and that has a default value of east-us. So we're going to be creating a resource group in east-us, and we're going to go ahead and give that resource group a name, and that's going to take this var.prefix. So it's going to take tf, and then it's going to go ahead and prefix that in front of this -resources string. So that'll go ahead and create a resource group for us with the prefix -resources and the specific location. So next up here we have the resource Azure RM virtual network. So essentially after we create our resource group as just a logical isolation of our resources that we're going to be provisioning. Then we go ahead and we need a way to network these resources so we can actually talk to them. So if we want to be able to talk to them publicly over the internet, or say we want these resources that are in a network to be able to communicate between themselves, they need to again be assigned. They need to be located within a network in a sense. So imagine a network to just be a pool, and in that pool you have a bunch of not volleyballs, but like those inflatable pool balls essentially, and you throw those in there, and those are just objects, right? So you have a pool with a bunch of pool balls, and that's essentially what a network is. And it's the way that you actually the way that these pieces communicate with each other is with IP addresses. So that's just a way to index the elements that exist in that pool. So we have again our resource. We now Azure RM underscore virtual network Azure RM underscore virtual underscore network, and we're going to call this main. So this means that when we reference this resource or this virtual network later in the program or in the code, we can reference it by the name of main. So you see, we'll talk about that when we get down to a few of the later resources. But essentially here, so we have name, and then it's again being prefixed with the interpolation syntax, so it's going to be provisioned as tf-network, and then it has an address space of 10.0.0.0/16, and this /16 is what's called the subnet mask. And what this allows us to do is essentially determine or it establishes the number of hosts that can actually exist inside that virtual network. So you're going to see as we later take this virtual network and partition it into a number of subnets, they're essentially going to be taking a portion of that address space for themselves. That's just again a way to create isolated networks for your resources to allow them to essentially communicate either within those resources or within those networks, or to establish a peering connection to essentially communicate between these subnets as well, or between these networks. So again, this is going to have a location, and now you see here how we assigned this name main up here. So we have Azure RM underscore resource underscore group dot main dot location. So that's referencing this variable right here, or this parameter, we'll say, of the resource group. And what this does is it tells Terraform that there is an implicit dependency between this virtual network and this resource group. So this virtual network cannot be created prior to that resource group being created, because it needs to, Terraform understands that, because we're going ahead and we're putting this sort of syntax here, which creates that implicit dependency. And again, so resource group name, again referencing the resource group. So again, this virtual network has to exist within a resource group, and this resource group is going to be referenced by Azure underscore RM underscore group dot main dot name. So you imagine, again, we could create another resource group, and then maybe not called main, but called like main. I don't know. You wouldn't typically use the name main if you're going to have a number of different networks. You'd create a cleaner way to essentially establish the contrast between them. But this is what we're doing here. So we have Azure RM underscore resource group dot main dot name. All right. So now we have a resource group for logical isolation of elements. We have a virtual network that is going to allow the components within that virtual network to be indexed by an IP address so that they can communicate. And then we're actually going to partition that virtual network into a number of specific subnets. And when we do that, that's what we're doing here. So we have resource Azure underscore subnet, or Azure RM underscore subnet. Again, this is a Terraform designated name for the Terraform interface to Azure. This is how it knows what kind of resource to create, and then we're assigning it the name internal, so that's how we're going to reference it later in the program. So again, we have name equals internal. This is the name of this subnet within the virtual network, and again, we have a resource group name, which is going to be the name of the resource group that we initially provisioned up here. So again, this is again an implicit dependency. This is saying this subnet cannot be created until this virtual network or until this resource group is created. And then we have a virtual network name, and we're referencing this virtual network up here, which means that this again another implicit dependency. This subnet cannot be created until both the resource group and the virtual network, and both the resource group and the virtual network have been created. All right, and then we go ahead and create an address prefix of 10.0.2.0/24, and this is again taking that address space of provided IP addresses that are made available to us right here, and we're again creating a partition of that for the hosts that are going to, or the objects that are going to exist inside this little mini pool, this subnet. So again, imagine one big pool, and then it has a bunch of little mini pools of the partitioned subnets, and that's how we go ahead and kind of break up the IP address space for the individual resources we're going to put within those subnets. So again, you can see it's kind of this big nested, like Russian doll kind of thing, where there's just a number of nested resources, and they kind of implicitly depend on each other, and we establish these implicit dependencies using this syntax of the syntax here, which Terraform interprets as the implicit dependency itself. Okay, so now we want our virtual machine to be accessible from the public internet. So because of that, we're going to go ahead and create a public IP object, just like you might instantiate a class. And this is going to have a name. We're going to prefix it with tf dash, and it'll interpolate to tf dash public IP. It has a location, which is going to be a location of the resource group, again implying that implicit dependency. It has the resource group name, Azure underscore RM underscore resource underscore group dot main dot name. So again, this is saying that this public IP address cannot be provisioned until the resource group has been provisioned, because there are two explicit dependencies here. So, but the thing is though, with Terraform, it tries to provision as many resources as it can in parallel by analyzing this, we'll say, graph of implicit dependencies to determine which resources it can provision ahead of which other resources to try to maximize efficiency. Next up here, we have the resource Azure underscore RM underscore, or Azure RM underscore network underscore interface, again with the main. And now you see we have main assigned to all of these different resources. But that's not to get confused, because the only time you're referencing main is sort of as a property of the Azure RM underscore public underscore IP. So you can consider that to be like a class, and then in that class we have this object called main, right? So we couldn't have two objects called main necessarily in that class. That's maybe not the best way to put it, but essentially this allows us to not overlap with our, you can't assign two things to the same name, but this is essentially the instance of this public IP object that's going to exist in that pool, which is our subnet. Okay, so we've got our name, and that's going to be the tf-public IP. And this is going to go ahead and give it a name to our IP address. The location, again, creating the implicit dependency on the resource group, meaning the resource group has to be provisioned first. So we have the resource group.main.location, so that's going to be the location of the resource group. We have the resource group name, and that's going to be there. So that essentially designates, okay, this public IP object is being created. What logical isolation or what group are we going to assign it to, and it's going to be assigned to the resource group that we provisioned above. And the allocation method is going to be static, so that means that the way that it designates the IP address is not going to change. It's going to be a constant IP address. All right, so next up here we have the Azure Network Interface. So every time that you have a virtual machine that wants to communicate in a network, or have networking functionality, it's going to need a network interface. This essentially is a thin, literally, interface that essentially allows networking capabilities, such as communicating with, say, other virtual machines in the subnet, communicating with the internet, communicating with other subnets, any kind of networking functionality you can imagine. It's going to need a network interface card. And that's what we create here. And so we say we have a name for this network interface card, tf.-nic, once that interpolation takes place. It's going to have a location, which is going to be the location of the resource group. It's going to have a resource group name, and that's going to be the name or the resource group we're assigning it to, referencing the resource group above. And then we have an IP configuration. So again, because this is our networking interface for our virtual machine, we have to configure how this IP or how this network interface card is going to be indexed in that pool of objects, right? And what index, and once it's attached to a virtual machine, how the virtual machine itself is going to be indexed. So we have a name, which is just going to be test configuration 1. We have a subnet ID called, we're referencing the ID of the subnet that we created earlier. So again, we're saying, again, if you imagine that Russian doll analogy, we're essentially saying, okay, this subnet, this IP this network interface is going to exist within that subnet. And then we go ahead and say private IP address allocation is going to be dynamic, and public IP address ID is going to be the public IP address that we created up here. So again, dynamic just means changing, and static means remaining the same. Okay, so next up here we have the Azure Virtual Machine. And again, we're giving it a name of main, and we're giving it, or we're assigning it the name of main for the purposes of this Terraform program. Then we're going to go ahead and give it a name for the actual virtual machine as it'll appear in the Azure portal, which we can take a look afterwards. And that's going to again be TF with the interpolation-VM. It needs a location and a resource group. So we're again referencing both of those properties from the resource group that we provisioned earlier. And then we have a list of network interfaces that we can attach to this virtual machine. So a virtual machine can have a number of network interfaces. In this case, it's only going to have one. So we're referencing this network interface that we provisioned above. And again, this is creating that implicit dependency, saying that this virtual machine is not going to be provisioned until the network interface card is provisioned, at which point the virtual machine can be provisioned and the network interface card can be attached to that virtual machine. VM size, so we're using a standard DS1_v2. This is a standard virtual machine size for production workloads in Azure. So you have the ability to essentially optimize for memory, which would be RAM. You have the ability to optimize for compute, which would be CPU or your number of cores. And these are all just different types of Azure Virtual Machine images or VHDs that you can essentially create and provision. And then we have a few other properties here. So delete OS disk on termination equals true, and delete data disks on termination equals true. So there's two types of disks. There's the OS disk, which is specifically for the operating system itself, and then we have the data disk, which is going to be allocated to or assigned to this virtual machine, and that's your typical, you might imagine, HDD, SSD type disk. And we can dynamically assign the size. Again, this OS disk is also in that kind of storage in a respect, but or in a sense. But essentially what we're doing here is saying that, okay, when we terminate this virtual machine, we do not want the operating system disk or the data disks to continue to exist. So you could have those continue to exist, and you could use that as a way to, you could reattach these data disks to different virtual machines. But in this case, we're just saying delete the disks. We no longer need them. So now we need to decide, okay, we're creating a virtual machine, we've given it a location, we've assigned it to a resource group, we've given it a network interface card for connectivity within the subnet, and now we need to decide, okay, what is the server that we are going to, or not server, what is the operating system that is going to run on this virtual machine? So in this case here, we have a publisher, we have an offer, we have the SKU and the version. And essentially, these are parameters that allow you to define the kind of virtual or the kind of operating system that is going to run on your virtual machine. So we go ahead and we say we want Ubuntu server. We're taking the 16.04 long-term stable, and we want the latest version. Now we define the storage operating system disk. So this is, again, the disk, the OS disk, yes. So this is the, let me see here, storage OS disk. Yes, so I believe, I'm gonna have to double check this one. The storage OS disk is the one that essentially is going to be the disk that is designated for any kind of, not specifically for the operating system, but that is going to be attached to our virtual machine. And in this case, we're giving it a name of my OS disk 1. It has a caching option of read-write. We're going to create it from a specific image, and that's going to come with the Ubuntu server, I believe. Again, I'm going to have to double check. This is one of them that I'm not 100% on, guys, so I'll add the details in the description on what those specific parameters are. And then the managed disk type is standard locally redundant storage, which means that we're going to get in one data. So if you imagine an Azure data center, it's going to be an Azure region has a number of Azure data centers, and we're actually just using locally redundant storage, which means we're going to have 3 copies of this disk in a single data center. So that's just in case again, there's going to be on Azure side, there's hardware failures that happen constantly, and they're rolling. There's going to be updating things constantly, and they're going to be patching things constantly. And so, in order to essentially maintain their service level agreements, which are essentially the uptime requirements and the uptime promises that they've made in regards to their high availability services and how available your data will be. They need to basically create these redundant copies, and in order so they can say patch one copy, or if one copy has some kind of unexpected downtime, that you can still continue to access your data while they repair that. And again, you have different options. You can do standard locally redundant storage. You can do redundant storage within the zone itself. Then you can do geo-redundant storage. So all of these things allow you essentially more redundancy and more safety in building your application. So it all depends on what your availability requirements are, what your recovery point objectives in terms of, say, all your systems crash and go down, and you want to recover them all up as fast as quickly as possible. What are the designations you're going to, or what are the amount of copies that you need to meet those recovery point objectives in a given time frame? So then we go ahead and we have the OS profile. And the OS profile essentially is, again, just a way to assign, okay, we have a computer name, which is host name, and we have an admin username and an admin password. And these are essentially just ways to how we're going to access the machine if we want to say secure shell into it, which we're going to do following this. And then we have OS profile Linux configuration, where we disable password authentication is set to false, which means that we can actually authenticate not with public and private keys, but with this password that was designated above here. So that was a lot. Remember, there's a hierarchy of things. They essentially have implicit dependencies on layers that exist, we'll say lower. So eventually we have the resource group, and then we go up a network, we go up a level to the virtual network, then we partition that virtual network into a number of subnets, and then we go ahead and we drop some objects in those subnets, like network interface cards, public IP addresses, and virtual machines. And then we go ahead and we create the kind of graph dependencies between those things, and Terraform kind of interprets that all again as a graph, and then it's able to provision those as many as it can in parallel, and also the resources that we designated to ultimately resort in the resources we designated. So now let's go ahead and take a look at a few commands. So I'm going to scroll up here. So now with Terraform, we can do this. We can go ahead and say Terraform init. Oh, and actually we should take a look at that too. So you need a provider. Looks like I don't have my provider file. It's a bummer. All right, so I'm gonna need to add that real quick. We'll go Terraform. Doing a little research on that OS disk thing a second ago. We're gonna do Terraform. What is it called? Why do I sometimes just not? I lose my words sometimes. Terraform Azure Provider. All right, and we're gonna need this right here. And what this does is it essentially allows us to initialize Terraform with this provider. So I already had it pre-initialized, but for the purposes of this demonstration, it makes sense to have this in here because you'll need this for yourself. So we go ahead and we configure this Azure provider. And now there's several ways that you can actually authenticate with Azure to allow Terraform to take contributor access to your, or to be able to create these resources in your subscription in Azure. And again, a subscription is like, if you imagine you got your resource group at the base of the file we just went, your subscription is just like one layer lower. So it's just like another building block that sits at the bottom in terms of, and it's largely related to your costs and what kind of support you want for your Azure environment. So what we can do now is I'm going to delete this Terraform. You see these plugins here, and then we have this Windows plugin, Terraform provider, Azure RM. So this is from previously, but we're going to delete that. And now we're going to run the command, we're going to save this providers.tf, and we're going to run the command terraform init. And so what this is going to do is go ahead and pull down that provider plugin for Azure. And all that is an interface to interact with the Azure cloud. And essentially what we're going to do is go ahead and once that provider is pulled down, you see this Terraform folder reappears. And then it has, again, that Terraform provider plugin. And you want to always version your provider as well, just to be safe. Always try to maintain just immutability in everything you do. Version everything, make everything immutable, and you're guaranteeing your safety in terms of configuration changes from yourself or from third parties as well. So let's go ahead now here and say, so now we did Terraform init, it downloaded the Azure interface plugin. Let's go ahead and do a Terraform validate. And that's going to go ahead and actually check over all our configuration files here that we have for Terraform, and we get a success, the configuration is valid. So now we can go ahead and do a Terraform plan. And what this is going to do, this is similar to a git add, right? Or say you were merging, no, it's not like a git add. Say you were merging a pull request for your project. So essentially, this is what you could see, right? So again, you have all these little pluses next to what's going to be added. Because what Terraform does is it creates a state file, and this state file is essentially a reference to all the resources that Terraform has created and that exist currently in the environment that are created via Terraform. So when you're creating your entire environment via Terraform, then you get to basically version your infrastructure and create this sense of immutable infrastructure as well, which is super powerful. It's a really good thing to have. So essentially what we're going to do here is now we see it's going to add all these things. It's going to add the the network interface, the public IP, the resource group, the subnet, the virtual machine, storage data disk, blah, 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 virtual network. So essentially, remember, we have subscription, goes up to resource group, goes up to virtual networks, goes up to subnets, goes up to little bits and pieces and objects that you drop in those subnets, and then you basically index them all with, or index them quote unquote, but assign them IP addresses, which are simply ways for them to communicate within their subnets or within peering subnets as well. So now that we have that plan, we see what's going to be applied when we try to provision this infrastructure. So let's go ahead now and do that. We'll do Terraform apply, and I think there's a flag auto approve, which will go ahead and we'll skip we typically would have to type yes to confirm that yes, we want to provision this infrastructure, but we're just use that flag and it's going to go ahead and do that all for us. So once this is done here, we're going to go ahead and look in the Azure portal under that resource group, and we're going to see all these resources provisioned. On top of that, it's going to spit out this public IP address that's going to be assigned to the virtual machine. So you guys can see here at the bottom, creating the public IP, creating the virtual network, creating the resource group, creating the subnet. So it's just interfacing with Azure right now. It's provisioning all these resources with the implicit dependencies, so there's no mix-up in terms of what belongs to what. All right, and so once this is done running, what it's going to spit out is this public IP address. And this public IP address is how we are going to essentially secure shell into this machine. So this is a Linux box. This is a Linux Ubuntu 16.04. It has secure shell. It's going to be enabled by default. We're going to go ahead and secure shell into that machine following this, so you guys can see. And this is a cool way to deploy your projects as well. So you can just take this template right here, and you can run those commands, Terraform init. Oh, and actually one that I missed, you do need to download the Azure CLI, and then you run AZ login, and you log into your account, and that's the way to authenticate with Azure prior to running Terraform. So you need to do that. I'll add the links for that as well in the description. But back to your projects. So if you want to create your projects and essentially deploy them on Azure, then you can go ahead and do that following this methodology. So you can take this template, you can literally just download the Azure CLI, run AZ login, log into your Windows or your Azure account, and then you can go ahead and run Terraform init. It'll download that plugin for you, Terraform plan to see what kind of resources you're going to provision. You don't need to do that, but you can. And then you can run Terraform apply. and that's going to go ahead and apply and provision all those resources up to your up as you designated in your code. And this is infrastructure as code, and it's a pretty neat thing. So what else is so typically with Terraform, when it comes to the state file, that is what is the kind of the bread and butter of Terraform. That allows it to always keep track of what resources are existing that it created and be able to destroy those resources with a single command if it so chooses. So you can instantly spin up entire huge architectures, and you can, or infrastructure architecture, there's kind of like opposite ways of looking at the same thing. But you can essentially provision the entire infrastructure at huge amounts and then just instantly destroy it all. And you can do things like, say, red-black releases. So if you're releasing a new version of your software, you can just go ahead and create a whole nother kind of instance of that software system. So you have two instances of the same software system, maybe like a version 1 and a version 2, and then you have a load balancer, and then all you do is you just you flip a switch in a load balancer, and it's going to flip your traffic going to your version 2. But say your version 2 has some like serious bugs, and your latency is falling off, your availability is falling off, then what you can do is just flip the switch back, and it goes back to your previous infrastructure. And this is all made possible very easily by immutable infrastructure, and specifically Terraform if you're doing multi-cloud deployments. So all of our infrastructure was provisioned. I accidentally cleared the out that we got, that is the public IP, so we can run Terraform outputs. Output, there we go. And so it's referencing, again, the state file to see what the most recent output was. And we're going to go ahead and get this public IP address here. So this right here, now we can run the command SSH. And now let's look at our provider here, or look at our OS profile. So we have our admin username of test admin. So SSH test admin at that IP address. And then it's saying, okay, it's connected to the host, saying the authenticity of the host cannot be established. We want to consider continue connecting. Yes, because we provisioned that host, permanently added that to our list of known hosts. And then we got to enter the password. So we're just going to take this password right here. And again, you wouldn't want to hard code this. You would want to have this securely stored or referenced in a variable file. This is not ideal, because you'd want to push your Terraform code up to some sort of repository, and then you have your password, your usernames, your PII, or personally identifiable information. Can't speak today. And then we'll go ahead and we'll paste that. But you'd want to have that separated from your code base. Permission denied. Try typing it. There we go. So now we secure shelled into our machine that we provisioned using Terraform. So now if you see, we're in a Linux box right now. /home /test admin cd, and then all your typical Linux folder structures. So essentially, guys, this is an awesome way to provision that infrastructure. And now what we can do is we can go ahead and look here at portal.azure.com, and I'm going to sign into my Azure account, and we're going to go ahead and look for that resource group. And that resource group, again, is called tf-resources. All right, and now we're going to go ahead to our resource groups. And we have tf-resources. Let's see what we have in here. And there we go. We have our virtual machine, our public IP, our network interface card, our virtual network, and our OS disk. So there we go. That's exactly how to use infrastructure as code to provision resources, spit out output files to allow you to quickly secure shell into your new machine, and perhaps deploy an application on that machine. And then if we want to, we can do this here. We can exit out of this bash session, and we can say Terraform destroy. And what this is going to do is reference that local state file that we have currently. Again, you'd want to typically have a remote state file. It's just for if you have multiple people working, creating Terraform code, when you're provisioning your infrastructure, it locks up the state files so you don't have any kind of, ball of mud is the term for software systems, but it applies here in the sense where you don't have a ball of mud of infrastructure trying to be provisioned without the implicit dependency graph that is necessary. So again, do we want to destroy all our resources? Yes. And now what it's going to do is tear down all of those resources, so we don't need to worry about any of those anymore. It doesn't cost us anything anymore, and it's really clean. So anyways, guys, again, thank you very much for watching. I hope you guys enjoyed this. This was kind of a neat look at a new a way of using immutable infrastructure to provision resources on multiple clouds. Specifically, we use Azure here, but again, you could use AWS, you could use GCP, you could use IBM, and you can even create your own API for on-prem to provision resources on-prem using Terraform as well. So it allows you a whole lot of flexibility. And yeah, that's about it. Anyways. Thanks, guys, and I'll see you in the next one. If you enjoyed this video, please subscribe, and a thumbs up would be great. Adios.